Welcome. So what I'd like to do is kind of introduce you to solving word problems with bearings. And in this example, what we're going to basically do is, look into how is a bearing, how do we describe kind of bearings, how are bearings used, and then how we can use them to solve our problem. So in the first problem, we're actually just going to be using bearings to create our picture. So therefore, we can use trigonometry to go ahead and solve for the problem. And in the next one, we're actually going to solve for the bearing. So I'll give you a couple different ways that we can represent bearings for you. So therefore, when you're working on a problem with bearings, you feel a little bit more comfortable. Now, just kind of give you a quick little recap of bearings. When we first introduced graphing angles in trigonometry, we started with the initial side of an angle at the positive form of the x-axis. And when we rotate to get an angle, counterclockwise, that was considered positive. And when we rotate an angle clockwise, that was considered negative. Now, when we're dealing with bearings, they're basically used very often in navigation. And what we want to do is talk about north, east, south, west. But bearings are kind of normal side. If I say like a bearing of 30 degrees, I'm not going to start from, in this case, due east, but I'm going to start from due north. So therefore, 30 degrees would look like this, because when we rotate clockwise, that is now in the positive direction, and counterclockwise is now in the negative direction. But we don't really use negative angles with bearings. Typically, we want our angles to be less than, less than 90 degrees. So if we're not doing an angle that's in, so we could use bearing from due north. So I could say instead of negative 30 degrees, I would say 330 degrees. Or we could also say, from due north, you're going to be 30 degrees west. Or you could say from due south, you're going to be 150 degrees due west. But we usually don't do that one where it's larger than 90. We kind of leave that there. But I'll kind of talk about that as we get to the problem. But either way, I just want to kind of give you a little bit of recap. And bearings are important because they're, as I mentioned, we'll be putting our answers a lot of times in bearing formats. And then also, you're going to be getting a lot of word problems where everything is in bearings, and we need to kind of dissect it. For example, this is that. For example, the first one. It says an airplane is flying at 600 miles per hour, has a bearing of 52 degrees. Now, once you see that 52 degrees, let's go ahead and graph what a bearing of 52 degrees would look like. So again, that's a bearing of 50 degrees. So that's going to be from due north, and 52 degrees, go right there. Now, we know that you're traveling at 600 miles per hour, has a bearing of 52 degrees, and you did that for an hour and a half. So therefore, at 1 hour, you traveled 600 miles, and then a half hour, you did 300 miles. So therefore, you're at 900 miles that you have traveled. So I'm just going to kind of put that in purple to distinguish my distance from my angle. And let's say now after flying, how far north and how far east will the plane have traveled from its point of departure? So basically, if this is 52 degrees, that means this angle is going to be complementary of that. So therefore, that is going to be 38 degrees. All right. And now what we have is we have a right triangle that we can create. And that's very, very important when we're going to be doing these problems for we're going to be doing problems, with bearings and in trigonometry. We're going to need to use our trigonometric functions. We're going to need right angles. So by doing all this, I go ahead and create an angle, or create a right triangle, that now I can go ahead and apply my x and my y distance, right? Because that's how far east and how far north and how far east would you have traveled. So y is going to determine how far north I will have traveled, and x is going to represent how far east I will have traveled. So therefore, I can say that the x, so x is going to be the adjacent side, so I can say the cosine of 48 degrees is equal to x over 900. And the sine, which is going to be opposite over adjacent, so the sine of 48 degrees is equal to y over 900. And so now I would just multiply by 900. If you remember my videos on trigonometry, multiply by 900 on both sides. And we could say that my x is going to be approximately, and let's just kind of round this to the nearest mile. So I'll do 900 times the cosine of 48. Make sure, again, your calculator is in degree mode. And that's going to be 602 miles. We'll just write equals because I'm going to round it. And y is going to equal 900 times the sine of 48, which is going to be 669 as I round to the nearest mile. Okay, so there you go, ladies and gentlemen. That's just kind of a basic, just a reminder, when we're talking about bearings, you're going to be going from due north, not from your standard position. In the next one, it says a ship is 45 miles east and 30 miles south of port. So again, we're just kind of set up our north, east, south, west. And it's saying that it's 45 miles. We'll say there's, I don't know why I'm doing this so big. Let's just do 45 here. And 30 miles south of port. Okay, so those are both miles. Now, since I'm going east and going south, I know that that's going to create a right triangle, and that's very, very, very important because now I can apply my trigonometry. And it's asking us is what is the bearing that will take him back there? So again, you got to think, where is the ship? If we traveled here and we traveled here, that means we're right here. We need to figure out what this bearing is. So if we're going to figure out bearing, we need to know our north, east, south, west. And in the next video that I make, I actually make this distinction a couple different times. I keep on trying to find my bearing, but I need to find this bearing. There's a couple different ways we can do that. We can figure out what this angle is. Okay, so we'll call this theta. Or we can figure out what this angle is, which I'll call beta. So there's a couple different ways that we could use bearings for this. Now, either way, let's go ahead and figure out what this theta is because that's inside the triangle, right? And that's going to be the easiest thing. So if here's my triangle, I know that here is going to be my hypotenuse. So for my theta, I have my opposite and the adjacent side. So I can say the tangent of theta is equal to 45 over 30, as the miles will divide out. So theta equals tangent inverse of 45 over 30. So let's go and figure out what that is going to be. So I'll do 45 divided by 30, tangent inverse. And I'm going to round to the nearest degree, which would be 56 degrees. 56 degrees. Okay, now that's very cool. Because one way that I could represent bearings is I could say from due north, I am going to go 56 degrees west. Right? From due north, I'm going 56 degrees west is going to take me back to port. Or I could use what beta is, so that was be doing what theta. And if you see beta is all the way around circle minus that 56 degrees. So basically beta is going to be 360 degrees minus 56 degrees, which in this case looks like it's going to be an extra, just a minus 360 if that's 56. That's my 45 over that, so that's going to be 56 degrees. Yeah, 60. I don't know why I was thinking 90. Yeah, so that's going to be minus 56. It's going to be 304 degrees. So from them here, so beta is going to equal 304 degrees. So from due north, I'm going 304 degrees in my clockwise direction. So therefore, I could also say a bearing of 304 degrees. So there you go, ladies and gentlemen. That is how you that's how you find the bearing, as well as use bearings to help find the distances in word problems with trigonometry. Thanks.